All right, welcome back, pre-calculus. Let's do some 7.3.2. We're doing hyperbolas. Now we're going to have to write equations, not if we have a graph, but when we're given characteristics. And you guys have indicated to me that you find these a little bit more challenging, which is good. We need challenging and easy, right? So the first thing we can think of is if we are given two vertices, if we're given two co-vertices, if we're given two foci, we can always find the midpoint between those two, and that's going to be our center. So we're given two vertices here, so my midpoint is going to be halfway between them. So 9 plus a negative 3, or 9 minus 3 divided by 2. Negative 2 minus 2 divided by 2. So my halfway point between these two are 9 minus 3 is 6, divided by 2 is 3. Negative 2 minus 2 is negative 4, divided by 2 is negative 2. So that is going to be my center. Now, if my vertices, they're going to help us figure out whether we're opening left, right, up, or down. Notice our vertices, and I'm one that always graphs it, so by all means, do this if you need help visualizing it. There's nothing wrong with making a little mock-up. That would be 9, negative 2, and 3, negative 2. So those are my vertices, which means my hyperbola is going to open up this way like that, because my vertices are the endpoints of that transverse axis that is kind of like your major axis, right? And halfway between those two, we said is 3, negative 2. That's my center. But since we're opening left, right, it's a horizontal hyperbola, which means the x's are going to come first. Got a minus sign, then my y's, always equal to 1. And my center is 3, negative 2, so it's x minus 3. Y minus a minus 2 is going to be plus 2. All right. What is the distance then between our center and either one of these vertices? What's the distance between 3 and 9 or 3 and negative 3? That would be 6. So my a value here is 6. 6 squared is going to be 36, so that's going to go under my x's. And then they said the length of the conjugate axis is 28. Well, half of that is going to be my b value. Remember, conjugate is kind of like our minor axis was when we were talking about ellipses. So it's going to give us a b value. Half of 28 is 14. 14 squared would be 196. Notice that this is not like ellipses where whichever one has got the transverse axis is not necessarily the bigger number, right? All right, number 6. This time we're given co-vertices. Where do the co-vertices lie? On that conjugate axis. So if our co-vertices are 3, negative 9, so 3, negative 9, and negative 13, negative 9, this is my conjugate axis, which means our transverse axis is this direction. So this is going to be a vertical. So it means somewhere up here and down here, I'm going to have my vertices, and this guy's going to open up or down. Why? Because the co-vertices are not the ones where we open up at. We open up at our vertices. Okay? So the distance between here and here, we're still going to find our center from the midpoint of that. So now we've discovered this is a vertical hyperbola. Why is that important? Because now we know it has a y minus squared minus x minus squared is equal to 1. Now we're going to go find all the rest. So where's my center? Well, it's going to be halfway between those co-vertices. So we use the midpoint formula. 3 minus 13 divided by 2, negative 9 minus 9 divided by 2. Remember, you're adding these guys. We're not changing any signs here, right? 3 minus 13 would be negative 10, divided by 2 is negative 5. Negative 9 minus 9 is negative 18, divided by 2 is negative 9. So we're going to have y minus a minus 9, x minus a minus 5. What's the distance between the center and the co-vertices? That number's going to go down here, but what is it? Distance between negative 5 and 3 would be 8. You can also see here, negative 5 and 13 would be 8. 8 squared would be 64. Now for our transverse axis, that's the one that goes underneath your leading fraction here. The length of it is 26. half of that would be 13. So my A is 13. 13 squared would be 169. Alrighty then. Let's try to do these two. All right, my vertices are 3, -3. So 3, -3 here, -5, -3 is over here. Since these are my vertices, this is going to be horizontal. It's going to open left and right. This horizontal, I know x comes first, minus y. We're going to find the center. So I can use either of these points. The midpoint between either of them will give me my center. So 3 minus 5, -3 minus 3. 3 minus 5 would be -2 divided by 2 is -1. -3 minus 3 is -6 divided by 2 is -3. So it's going to be x minus a -1, y minus a -3. What's the distance between my center and my vertex? Either one of these. They're 4 units away. 4 squared is going to be 16. And now what's the distance of the y's between my center and my co-vertices? So between -3 and -10 is 7. 7 squared is 49. All right, let's try to get one more on this video, and then we're going to get to some harder ones that have foci. I'm going to use the midpoint to find my center. So -4 minus 4 divided by 2, 11 minus 13 divided by 2. What's -4 minus 4? -8 divided by 2 is -4. 11 minus 13 would be -2 divided by 2 is -1. All right, if our vertices are at -4, 11, and -4, -13, these are my vertices, so we're going to be opening vertically. So this is a vertical. If we have a vertical hyperbola, which variable is going to come first? The y. So I got y minus squared minus x minus squared, always equal to 1. Go ahead and plug in our center. So y minus a -1, so y plus 1. X minus a -4, so x plus 4. Now the distance for my y's from the center to the vertex, -1 to -13 would be 12. 12 squared is 144. The distances between my x of my center and the x of my co-vertices is 7. 7 squared is 49. All right, that's it for 5 through 8. When we come back, we're going to start messing around with some foci and hopefully get the next 4 on the next video.